Let us discuss an engineering blueprint of the large language model lifecycle today. It has 6 steps. Step 1 is the data cleaning tokenization process. Step 2 is a positional encoding that will decide the position of the words within the sentence in the transformer. Step 3 is a model tree training process. And step 4 is the fine tuning of the models on a specific data set. And step 5 is the model alignment process. And step 6 is the decoding strategies to generate the output format of the LLM. We will discuss each of these steps today in detail. Let us discuss the step 1 of the LLM life cycle, which is called the data cleaning and tokenization process. This has 2 phases. One is macro data refinement funnel. This process will collect the data from various URLs or websites, and that will be performed the URL filtering process. Then this will also perform the language detection on various URLs and segregate the data on different languages. And there is a deduplication process will be performed to identify a unique data from the various websites, and this data will be stored in the databases. Then the tokenization process is performed on the text data. This includes the various methods such as the byte pair encoding and word piece encoding and sentence piece encoding methods. These methods will be applied for different languages in different way to efficiently represent the text data for the LLM training process. Let us see the macro data refinement funnel. This process collects the various data from the websites in the form of raw inputs, unstructured data, sensor streams, and also the sensor readings in time series data. So the first step is the data cleaning, which filters explicit content from the social media streams and also the toxic data from the text data. Once the filtering process is completed, there is a data integration process that deduplicates the existing data to make sure that the data is consistent. After the data integration is performed, there is a transformation phase that will convert the entire data into a normalized stage and also tags the data in the form of topics. After the transformation phase is completed, the enrichment phase will be performed. If new data comes, it will be go through some of the steps to make sure that it will be added to the existing transformed data. Then all this transformed data will have the structured insights and actionable intelligence. There is a matrix attached to this data to make sure that the quality of the data set is good. Please subscribe, like, comment for more technical videos. After macro data refinement funnel process, we will be looking at the text encoding methods in large language models. There are 3 types of text encoding techniques: byte pair encoding techniques, word piece encoding techniques, and sentence piece encoding techniques. In byte pair encoding techniques and word piece encoding techniques, subwords are detected from the existing words. Whereas in sentence piece encoding techniques, it will consider the entire sentence as a word and subwords are detected from the entire sentence. So in byte pair encoding and word piece encoding, the way in which the subwords are calculated will be differed. In byte pair encoding, the frequency based subwords are calculated, whereas in word piece encoding, the probabilistic subwords from the vocabulary is used to calculate the subwords. Byte pair encoding is used in the GPT-2, GPT-3 architectures, whereas word piece encoding is used as BERT, Distill BERT, and Electra models, whereas the sentence piece encoders are used in T5, Albert, ExcelNet, and GPT Neo models. Let us discuss the step 2 of the LLM life cycle, which is called positional encoding. The initial transformer architecture uses the absolute positional embedding, which is rigid in mapping, which means that it restricts the maximum token length and ignores the relative distance between the words, which means every word in a sentence has equal weightage to attend all other words. This is extended using the rotary positional embedding, which uses the rotation matrix. It is highly flexible with the sentence lengths and it has the relative weights to attend every word in the other words. When the distance between 2 words increases, the attending weight will be also decreased. Here, there is a third type of attention mechanism called the attention with linear biases, which adds the penalty to attention scores, which is proportional to its distance, and it is excellent for extrapolating the sequence length beyond its training sequence. and it is used in the Bloom architecture, whereas rotary positional embedding is used in the Llama and Palm architectures. Let us discuss step 3 of the large language model life cycle, which is called model pre-training. This has two core paradigms. One is autoregressive language modeling, second is masked language modeling. Autoregressive language modeling is used in the decoder only architecture. It performs to predict the next token, taking into account the previously seen tokens only. Whereas this masked language model will be used to identify the masked word within a sequence by looking in all the surrounding words as a context. This is a standard process in the encoder only models. And there is a third type of model is called the mixer of expert models. This mixer of expert models are used to scale up the model parameters dynamically without a proportional increase in the computational cost. What happens is that initially we have the dense representation of the feed forward neural networks. So when you increase the number of layers, the number of parameters will be increased. That requires the huge computational cost. In order to reduce that one, dense feed forward neural network is converted into a sparse representation of the feed forward neural networks using a router. The router has ability to see the incoming tokens and identify which expert this token needs to be passed. Based on that routing mechanism, it can able to reduce the dense representation of the feed forward neural network into a sparse representation that will scale up the model parameters dynamically with the less computational cost. Let us discuss the step 4 of the large language model life cycle, which is called fine tuning and instruction tuning. The initial large language model is a pre-trained language model on a publicly available data set, which is also called foundational models. When you want to use the foundational models on your specific data, there are two ways to fine tune the foundational models. One is supervised fine tuning, another is instruction tuning. In supervised fine tuning, you will have the training data which is labeled with class labels, and you will use this training data to fine tune your large language model using supervised fine tuning. There is no instructions available for this process. There is another process which is called instruction fine tuning. This process, you will have the natural language instruction to perform the tasks on the large language models. You can fine tune the pre-trained language model based on the instructions and the results using the FLAN architecture, which is a fine tuning language nets. And they have one example you can see here is that the plan uses the Palm architecture on 1836 distinct tasks that improves its performance by 9.4% on zero shot learning. The fifth step of the large language model life cycle is called AI alignment process, which steers the large language model towards the human goals, preferences, and principles. The first method is called reinforcement learning based human feedback. In this process, it builds a complex reward model from the human preference data to improve the model performance. It is very effective but highly unstable. The second method is called direct preference optimization model. This will bypass the complex reward model by converting the preference data into a classification data, which will improve the model performance. This model is stable and computationally lightweight. The third type of process is called Kaminan-Tversky optimization. This process converts the preference data into a binary data. So it will be like a thumbs up or thumbs down, which massively used in the real world customer data process to get the human feedback. The step 6 of the large language model life cycle is decoding strategies. It has various types of decoding strategies. Starts with greedy search. This takes the highest probability token immediately when generating the sentences in the decoder side. It is very fast but lacks the temporal coherence. The second type of strategy is called the beam search. The beam search tracks the top n most likely sequences to be generated. It is computationally heavier but yields a better global sequences. And the third strategy is called top k sampling. This is where you get a creativity which selects randomly top k most likely options for generating a word in a sentence generation process at a decoder side. Here you can set the temperature and go for the more creative way of generating the sequences. And there is another method called top P sampling. This method dynamically pulls the tokens whose cumulative probabilities exceeds threshold P, that allows high diverse outputs. So top K sampling and top P sampling would be used for the creativity way of generating the output sequences. And the greedy search is a faster one, but it lacks the temporal coherence. And beam search is a very slow, computationally heavier, but it gives the better global sequences. Let us conclude this talk. We have discussed the 6 steps for the LLM life cycle, and we have also discussed in detail methodologies how that has been performed in the large language model life cycle. Please subscribe, like and comment for more technical videos.